Look at the way the light filters through these leaves and tracks across the subject's face. 6 months ago, capturing a sequence with this level of photorealism and dynamic lighting required a massive crew, a dedicated location, and a cinema camera. Traditional filmmaking pipelines are bottlenecked by heavy costs. Expensive pre-production storyboarding, location scouting, and disjointed post-production software consistently locked independent creators out of high-end execution. AEVA CINEGEN bypasses those barriers entirely. It operates as an all-in-one artificial intelligence studio that handles the entire production pipeline, from your initial script idea to the final exported video cut, inside a single platform. This diagram illustrates how the system divides the labor. When you provide an input, the platform splits the processing into 2 specialized engines. Google's Gemini story engine handles the narrative logic, structure, and text, while Google's Veo motion engine calculates the physical rendering and video generation. To achieve the highest volume of generations, your first step is navigating to the Settings menu and connecting a Google Cloud account. This links your workspace directly to a $300 API credit, giving you the bandwidth needed for a complete production. AEVA bypasses the piecemeal approach to video generation. It places a complete, multi-department production studio inside one unified dashboard. Step 1 in the workflow happens in the Brainstorm Studio. You start by typing a single sentence outlining your core story concept. The engine moves beyond basic text expansion. Using the Gemini Flash and Pro models, it builds a deep-layer script architecture. Gemini Flash is a lightweight, highly efficient AI model designed for rapid reasoning and multi-model tasks. This diagram shows the initial text string unpacked into distinct structural elements. The system maps out emotional arcs, detailed character blueprints, and location metadata. This data becomes the foundational DNA for your project. Subsequent visuals directly reference these locked parameters to ensure accuracy. A single prompt is now a fully formatted, ready-to-execute production blueprint. The traditional failure point for generated video is inconsistency. Characters will often suffer from pixel shifting, where their facial features and clothing morph unpredictably when the camera angle changes. Inside the character system dashboard, you solve this by activating the Identity Anchor toggle. This diagram illustrates the identity anchor. It converts text and visual traits into a mathematical space, locking facial features and costume details to rigid data points. Because these are locked, prompting different lighting scenarios outputs the exact character identity. Achieving pixel-level identity consistency turns generation from a visual experiment into a reliable, repeatable narrative tool. With the characters locked, we move into the shot engine, where your storyboard frames are prepared for actual video generation. Here, you activate the Google Veo motion engine. Veo calculates the physical accuracy of the scene, dictating how objects interact, how gravity behaves, and how the camera moves through the space. Watch the way the smoke clears and the water ripples in this sequence. The temporal consistency holds up flawlessly under complex environmental interactions. The render achieves high optical precision by natively incorporating subsurface scattering, the way light penetrates and diffuses beneath a surface, like human skin, and ACE's color science. The Academy Color Encoding System is the industry standard for managing color workflows, ensuring consistent cinematic hues across different displays. The physics engine successfully replicates the optical behavior of high-end camera sensors and practical lighting grids. Once the visuals are rendered, they require a precise soundscape. This happens in the audio suite. The platform handles sound through a dual generation process. It utilizes Google TTS to convert written script into lifelike spoken dialogue, and the Lyria model to compose custom cinematic musical scores. To maintain high fidelity and strict pacing, the system generates these assets as short, precise clips, rather than attempting to output one massive, continuous file. This image shows the multi-track nonlinear editor, or NLE, located in the editing bay. An NLE is an interface that allows you to arrange, cut, and mix video and audio clips independently on stacked tracks. Here, you will drag and drop your generated video clips, sync your TTS dialogue waveforms, and layer your Lyria music. By integrating a native editing timeline directly into the platform, you secure your final cut without ever needing to export files to third-party software. With your clips assembled and mixed, your final step is exporting the sequence. You have two pathways for export. You can render a direct, high bitrate 4K master file for immediate viewing, or you can export native project files that are fully compatible with external professional workflows like Adobe Premiere Pro and DaVinci Resolve. For distribution, the platform includes a key art studio. This generates polished, theatrical quality posters complete with custom billing blocks. You map the narrative logic, lock the identities, calculate the physics, and assemble the timeline. The result is a fully realized sequence with dynamic motion and polished lighting, built entirely from a text prompt. The friction between having a concept and executing a final master is gone. Navigate to AEVACINEGEN.com to launch your studio and start building.